means not in detail we will be going. Only in short we will deal with what is the transformer concept, one the different parts of the concept in short, and then we will deal the whole syllabus in detail next time. Okay. So I will share you the PPT related with the first unit. Are you able to see the slides? Are you able to see the presentation?
Yes,
Yes,
sir.
ma'am.
Now in the first slide, you just go through the syllabus which is there related with your first unit, and accordingly you will be dealing it with one by one. Okay. Now this is your simple transformer construction or the symbol of the transformer, which can be represented by a different way. Now, when you talk about the transformer, you will see that this is normally the construction of the transformer which we use in the educational purpose. And this is nothing but the symbol of the transformer which we will be using throughout for our further study. Now, when you talk about the transformer, the name itself, the English meaning of the transformer is what? It is a transforming. But what it is transforming? It is transforming the electrical energy from one side to another side, or it is transferring, in short, the energy or the power. So you define the transformer as a static device or a stationary device. Why so? Because if you see the construction of the transformer, it is a stationary in nature. There is no moving parts present in it. So you name it to be a static device or a stationary device by means of which the electrical power in one circuit is transferred into the electrical power in the second circuit, keeping the frequency same or without any change in the frequency. Now, whenever it is transferring the power from one circuit to another circuit, it can either step up the voltage here or it can step down the voltage. But when the process of increasing or the decreasing of the voltage takes place at the other side, in such case, the corresponding current which is associated with also increase and decrease. Means what? If my voltage is increasing in this side, the current will decrease. If my voltage is decreasing, the current will increase. Means in short, whatever the power is transferred here will remains the same on the second side. And the working of this physical transformer or the physical basis on which the transformer is transferring the power from one side to the another side is nothing but because of the mutual induction which is present between the two circuit, which is linked by a common magnetic flux. Or in a simple form, we can say that in a transformer there are two circuit present or two inductive coils are present which are magnetically linked but they are electrically separated. Means what? they are magnetically linked with a path of low reluctance as it is shown in this figure if you see the color notation, and they are electrically separated because there is no relation between the electrical parameter of one side and the electrical parameter of the second side there. So you will see here that these two coils which are present, they are having high mutual inductance. And if you are connecting one coil here, that is, if this coil is connected here to my AC voltage, then what will happen? And alternating flux, this flux which is written here, an alternating flux is produced, which is set up or it is linked or it is flowing in the magnetic or the laminated core here. So it is flowing or it is set up in the magnetic core there, most of which is linked with the coil which is present on the first side as well as the another coil which is present here. Thereby, according to the Faraday's law, it induces the self-induced EMF in the first coil and the mutually induced EMF in the second coil there. And if your second coil is closed or a load is connected to the second coil, then you will say that the current will flow through it and the electrical energy is transferred entirely magnetically from my first coil to the second coil. So this first coil in which the electrical energy is fed is always known as your primary winding, and the second coil through which the energy is taken out is known as the secondary winding there. So, in short, we can say that a transformer is a static device that transfers the power from one circuit to the second circuit. At the time of doing this, it there is no change in the frequency. That is, if your input side the frequency is 50 hertz, then the frequency of the secondary side will also be 50 hertz. Then this principle or this process is nothing but accomplished by the principle of the electromagnetic inductions. And most over important thing is that these two circuits, they are electrical in nature, but they have a mutual inductive influence on each other. So the simple transformer, if you see, this is nothing but the simple construction of the transformer. And this construction of the transformer is basically decided by the principle on which it is working. Now, the principle on which your transformer is working is the Faraday's law of magnetically induced EMF or electromagnetic induction. What the electromagnetic induction is taking according to this principle means what, whenever that is the flux means rate of change of flux is nothing but your what we say the concept means d phi by dt. Okay, now here you will see that when you are this in the construction, you will see that you are having two part. One is the magnetic core here, which is shown by the rectangle symbol here, and second part is nothing but your winding here. Both are static in nature, but according to the electromagnetic principle of mutual induction, your EMF is induced. Okay, that is E is equal to M di by dt, where M is your mutual inductance and E is equal to L di by dt, where L is the self inductance. So you will see here when the primary coil is connected to your supply, you name this part to be the primary circuit and the winding is named to be the primary winding. Similarly, the second part is nothing but the secondary circuit to which always the load is connected and the winding is named to be the secondary windings. Both this primary winding and the secondary windings, they are wound on your magnetic core which is having a path of low reluctance. When you are connecting the AC supply to the primary winding, what will happen? The circuit is closed, and according to this, what will happen? The current will flow in the winding. Now, the current which is flowing, it is alternating in nature. Since my voltage is alternating, the current is also alternating. Because of this alternating current, the flux which is flowing in the core is also alternating in nature. Because of this alternating concept, what we see is whatever the flux is produced, it is linking my secondary winding as well as it is linking my primary winding. Because of this alternating flux, what will happen? When this alternating flux links my secondary winding, according to the principle of Faraday's law of electromagnetic mutual induction principle, the mutually induced EMF is induced in the secondary side and the self-induced EMF is introduced in the primary side. And when you are connecting the load, the power which is present in the primary side is given at the output or on the secondary side there. So based on the Faraday's law, there are two parts present. One is the magnetic core and second is the winding present there. Where you will see that these two coils which are present, that is the primary coil and the secondary coil, they are having the mutual inductance and a steel laminated core is present there. These two coils which are present, they are insulated from each other and also and the steel core also. So every insulation is provided between all these parts, between your primary and the core, secondary and the core, and as well as between both the primary as well as the secondary. There are different parts present in the transformer also. Now, if you see, there are the transformers which are installed on the roadside. Now, when you approach towards the college, you will observe the transformer is present on the right hand side at the corner. Okay. So the transformer which is installed is a three-phase transformer. And from that three-phase, we are having a single-phase supply there. So whatever the means we say power which is generated at your generating station, it is a three-phase in nature. This three-phase power which is generated is from the generating station, it is first transferred to the transmitting stations with the help of a three-phase transformer because whatever the power is generated, they are nothing but a three-phase in nature. So you have a three-phase transformer and the transformer which is installed at the generating end, it is my step-up transformer. So whatever the power is generated at the generating station, it is a step up and then they are transferred. This transmitted power is now bought at the transmission station. From the transmission station, or these transformers, they are known as the transmission transformers. From the transmission stations, again the power is stepped down and they are transferred to the distribution station. At the distribution stations, whatever the transformers are installed, they are known as the distribution transformers, which are of different nature. That is, all the transformers which are installed at the distribution, they are again the step down transformers, which step downs the transmission power into the distribution power there. And from the distribution transformers, the powers are distributed to the residential area, commercial area, and the what we say to the industrial area. In the residential area, mostly we have a single phase 230-volt supply. But depending upon the requirement, if anyone needs, you can have a three-phase supply. But most of the time, we have a single phase 230-volt supply with two current range. That is either 5 to 8 ampere or 15 ampere. So you will observe that in our house, we are having two types of power plugs. One is the 8 ampere plug and second is the 15 ampere plug there. So voltage remains to be the same in a single phase. In the commercial area, you are having both the supply, that is a single phase as well as a three phase, depending upon their requirement. And in the industrial area also, you have a single phase for the lighting purpose and the three phase for their industrial purpose. But depending upon the classification as per the residential, commercial, and industrial, the tariff rates are different. That is, the unit charge or the rate per unit is different for all these three areas. So basically, the transformers which are installed, they are three phase in nature, and depending upon the requirement, the single phase supply is given. So depending upon the load of that given area, you decide the rating of the transformer. Suppose if we consider the Sahkar Nagar area or our college campus, if you say, suppose if we are having a 100 ampere capacity is the load there. So you installed the transformer, that is a three-phase transformer is installed in such a way that it will give you 230-volt 100 ampere. So how much is the total rating? 230 into 100 means how much it is? 23,000. So 23,000 means what? How much will be your two third? How much it will be? It is your 2.3 MVA, means near about 5 MVA transformer is installed in our college campus. And from each phase, the supply is given to the different parts there. So depending upon the load capacity of that particular area, the transformer capacity or the how much rating of the transformer should be there is decided. But an additional provision is also provided in the residential area. Suppose if my residential area, three societies are there and fourth and fifth society is expected in future. So in that case, considering the load capacity of all the five society, you take the transformer. And once three societies are been built up, the supply is given to those three societies. After the fourth society construction is over, the supply of the fourth society is also given through the same transformer. So that additional provision is done. What we say to be the loading of the transformer. Okay. So whenever you are having a power which is being transferred, it is always through the transformer which is transferring the electrical power from one circuit to the same circuit, keeping the frequency same. This is what the basic concept of the transformer. So I will stop here, and in the next lecture we will be actually dealing with the how what are the different types of the transformer, how the windings are being placed on the transformer, and the construction of the transformer. This is nothing but the actual construction of the transformer what we see at the generating station, transmission station, and the distribution station, what you name to be the correlated transformer. Means what? The whole these transformers, when they are dipped in the container, they will act as your correlated transformer. Okay, so just wait a minute. I will take your attendance, and then you can go leave the classroom. Just wait a minute. One, two, three. See now, as per the new roll number, now there is slight change in you.